In the next video, we're going to actually start doing some examples that you might see in Delta Math. The previous video is more definitions. So let's go ahead and let's start with converting. So my first example I want to do is let's go ahead and convert degrees to radians. And just as a reminder, you're always going to be multiplying by something to do with 180 and pi. If I'm going from degrees to radians, I need pi in the numerator and 180 in the denominator. So let's go ahead and just pick some numbers. Let's go with 30 degrees, and then we'll go with something like, let's do maybe 75 degrees is fine. So a couple things are going to happen here. First of all, it starts off very simple. You take 30 and you just need to multiply by pi over 180. And that's pretty much the answer, but let's go ahead and think about what's really going on. Let's go ahead and take a look at our calculator. If I do 30 times pi over 180, notice I don't really get a nice number, 0.523, and I talked about this in the previous video. I don't really like radian measures to be in this form because it's not helpful. So what we're actually going to do is I almost ignore the pi, and I just think about what 30 times 1 over 180 is, and then I know I'll just put in the pi later. So think about this 30 times 1 over 180. It's really just 30 over 180. And you might already see it. You can reduce that fraction, or you can click this button over here to get 1/6. So this means I'm going to end up with 1 over 6 pi, which we usually write as, so the pi goes up, we write this as pi over 6. The reason pi is up there is because notice it starts in the numerator, and so it has to end in the numerator. And so then my answer would be pi over 6. I prefer this format, so I prefer you to leave your answer in terms of pi. And so usually what you'll see on a problem, and if I forget, just assume it is, but I'll also write in terms of pi. Okay, let's go ahead and do the next one. So remember 75, all we really have to do is multiply by pi over 180. But let's go ahead and see what this fraction is. 75 over 180 would give me 5/12. So this is 5 pi over 12, and that would be my final answer. Okay, now let's go in the opposite direction. So what we're going to do next is convert radians to degrees. Now, in this case, you're never going to have to worry about leaving anything in terms of pi. So if you ever do have a decimal, I would have to specify on here how many decimals I want. Let's say 1 decimal place if needed. Okay, so the first one, let's go ahead and do, let's say pi over 4. This is a pretty common one. And then maybe we'll do 3 pi over 7. All right, so keep in mind we are now multiplying by 180 over pi. So what I would do is I would take my pi over 4 and I'm going to multiply by 180 degrees over pi. Notice in these problems, most of the time, you're going to end up with a pi divided by pi, which is just 1. So really, I just need to do 180 divided by 4. You could do the whole thing out though, as well. It really doesn't matter too much. It's just fewer things to type, I guess. So I end up with 45 degrees. Notice I could just do 180 divided by 4, and I end up with the same answer. So this would be a 45 degree angle. So we didn't have to round in that one. Okay, now let's multiply 3 pi over 7 times 180 over pi. Notice the pi's will cancel. So what I can really do is just go 3 times 180 divided by 7 You can convert this to a fraction, but in this case, the degrees, it makes more sense to think of about a 77.1 degree angle. That makes a lot more sense to me than a 540 over 7. I also specified in the problem that I want you to round, so we'll go ahead and just say this is approximately 77.1 degrees. Now, before we go on to some other problems, I want to do one last example, and I want to just convert what 1 radian would give me. So 1 radian is kind of weird because I've been talking about answers in terms of pi. Notice this doesn't have a pi. I'm just saying this is 1 radian. And this kind of compares the others. So if I did 3 pi over 7 on here, that was a 1.3 angle. So we know that 1 radian is a little less than this one. Or if I did, whoops, if I did pi over 4, notice how this is 0.78. So this 1 radian is probably going to be somewhere in between 45 degrees and 77 degrees, just to give you kind of an idea of how that works. All right, let's go ahead and do this. So I'm going to take 1, and I'm going to multiply by 180 degrees over pi. Notice I'm leaving off the radian unit measure. That's because, like I said before, radians is not really a unit. It's more of a ratio. So let's just do 1 times 180 over pi. I end up with 57.3. So one thing that's helpful to remember is that 1 radian is kind of close to 60 degrees, right? It's a little bit less, but this is sort of a good rule of thumb to keep in the back of your mind. It won't work if you're actually solving problems. You would need to actually convert this. But just to give you a good way to estimate, whenever you have 1 radian, that's about 60 degrees. So if you're ever doing a problem and you end up with something like 2 radians and you get an angle, let's say you have a 2 radian angle and you say, oh, this is 2 radians. You say, well, wait a second, 2 radians is actually 120 degrees, which is between 90 and 180, so I'm in the wrong quadrant. So that's just a good way to estimate what a radian is. Speaking of what a radian is, the way it's technically defined is if you have any circle, and let's say that circle has a radius of r, so here's my circle. This is r, right? So its radius is r. 1 radian is defined as if you took that radius and sort of wrapped it around the circle, you can kind of imagine that it would look like this. So that's length r, this is length r, and then around the circle that is also length r, and then this is the angle for 1. If you walked 1 radius around the circle, so for example, let's say this was 2 feet or something. If you walk 2 feet around the circle, then you would have gone 1 radian of angle in rotating around the circle. Okay, anyways, that won't really help you solve problems or anything. That's just where radian comes from. Okay. So let's talk more about coterminal. We're going to say find coterminal angles to the following. So let's start with 2 pi over 3. Now remember, we talked about coterminal before. We said you had to add or subtract 360. Well, with radians, 360 is equivalent to 2 pi. So we'll be adding or subtracting 2 pi to this. So if I want to find one positive and one negative, which often happens, in this problem I'm not really specifying because I just want to talk about coterminal. But let's say I want to find a positive angle that is coterminal. I could take my 2 pi over 3. You can always just double check where this is by converting it if you want. But then I would add 2 pi to it, which means I've gone around my circle 1 full rotation. What I usually do in these problems is I kind of ignore the pi's for a bit and just think about 2/3 plus 2, and then I'll throw the pi on later. I'm sort of factoring it out. And you can add fractions on calculators if you want to do it this way, or you could do it with a common denominator. So I end up with 8/3, and so we can just say that this would be 8 pi over 3, and that would be my final answer. Alternatively, you could do 2/3 and then 2 with a common denominator would be 6/3, and then you get that. And you could keep going. So once you have one, you could just keep going and finding more and more coterminal angles. So now I have another angle. These are different angles, but they are coterminal. Usually, though, you want to find a negative angle as well. So let's talk about how we might do that. Instead of adding a full rotation, I can just subtract it. So instead I can go minus 2 pi over 3. And I'll do this the same way. I'll just take my 2/3, and I'll go ahead and subtract 2. And so I get negative 4/3 pi. And so I've now found two coterminal angles, and you could keep going with that. You could keep subtracting 2 pi if you really felt like it. And so you can find, there's actually infinitely many coterminal angles to every point. Now, if you don't like that method, maybe you're still getting used to radians, there is an alternate way to do it. What you could do instead is first take 2 pi over 3 and convert this to 2 degrees. So 2/3 of 180, the pi's cancel, gives me 120. And then what you could do is say, well, I need 120 plus 360, and so you'd end up with 480 degrees. And you could also do 120 degrees minus 360, and this would give you negative 240, I think. And so now you have your two coterminal angles. You do now have to convert them back. So we would go, well, hopefully we get the same thing, right? 480 divided by 180, and I get 8/3 pi. And I'm guessing this one's going to give me that negative 4 pi over 3. So that's an alternate method if you prefer to convert to degrees and do it that way. Or you can just add and subtract 2 pi. Okay, let's try another one. So this time I'm going to do 18 pi over 5. And the reason I want to do this is notice that this number is actually bigger than one full rotation. So I already have an angle that's going around 2 pi and then an extra however many, I think it's 8 over 5. So it's going to end up somewhere over here. So in this problem, once again, let's just say we wanted a positive and a negative. So for my positive, I could still add 2 pi to that. And so I would end up with 28 pi over 5. So there's one coterminal angle. And then if I want to get my negative, if I subtract 2 pi, that's going to give me a positive 8 pi over 5. So I haven't done my negative coterminal yet. So what I'm going to do is just keep subtracting until I get to a negative number. And so now I have a negative coterminal angle. And you could keep going as well. If you didn't like negative 2/5 for some reason, you could keep going and get negative 12, negative 22, whatever you end up with. But that's how you find coterminal angles if you ever need to do that, which we probably will in a future unit. Okay, finally, the last example I want to do is find a complementary angle. Let's talk a little bit more about this. And really, this is just more practice dealing with radians. That's why we're doing these problems. So let's go with, let's see here. I think I wanted to do 3 pi over 8, that's what it was. Okay, so just remember now, to find the complementary angle, we're talking about some unknown angle that will give me pi over 2. So solving for theta, I'm going to take pi over 2 and then subtract 3 pi over 8. Once again, if you want to do this with a common denominator, you sure can. So this would be 4 pi over 8 minus 3 pi over 8. My common denominator is 8. I multiply top and bottom by 4. Combining the numerators, I end up with just 1 pi over 8. Alternatively, you could say pi over 2 is just 1 over 2 minus 3 over 8, which would give you 1 over 8, which is pi over 8, which is exactly what we found. And then we could also do something with supplementary, so we could find the supplementary angle. Let's go with 2 pi over 5. Now in this problem, we need to get them to add up to pi, right? So, whoa, that's a weird 5. We need this to add up to 180 degrees, which is just pi, right? I don't think I mentioned that up here. Pi over 2 is 90 degrees. That's something you should know off the top of your head, because it's half of pi, and remember pi is 180. So these are the big ones, the big 4, because those are each of the axes, right, as you're going around. Okay, so this has to equal pi, so that means that theta is pi minus 2 pi over 5. So 1 pi is the same as 5 pi over 5, so we see that this is just going to be 3 pi over 5. Alternatively, you could use the calculator. You would do 1 minus 2/5, and that would give you 3/5, and then you just put the pi on there. Okay, so that concludes our sort of basic problems using radians. Once again, I know this is all pretty straightforward with degrees, but part of what we're doing in this unit is just practicing radians, because these come up a lot, especially in calculus. When you get to trig and calculus, you do a lot of radian stuff. So we're going to keep sort of hammering radians until it becomes really easy for you to deal with. I'm always fine if you want to convert radians to degrees and then work with the degrees and then convert them back at the end. You should just understand how all of that works and be very comfortable and fluent with it.